Hey everyone, welcome back. We're going over osteology or the study of the skeletal system and bone in particular, but we're going to go over cartilage and bone for right now. So here are the divisions. So you'll need to know a few things. You'll need to know about these three key types of cartilages, and we'll get more into the skeletal system later, but right now I just want you to be familiar with what parts are considered axial and which parts are considered appendicular. So for the cartilages, everything denoted here in this like nice light blue, as you can see here and throughout the rib cage, also at the epiphyses of the bones. Oh, and of course the nose here. These are all hyaline cartilage. They're relatively stable. They're structural in nature, but they do have some degree of flexibility. They are used for either connective, they actually make some of the physical structures and scaffolding themselves, or they're used to kind of be a little bit of let's see, a friction barrier, but not as much as some of the others, like the fibrocartilages. Okay, so elastic cartilages are similar to hyaline cartilages in that they are structural. However, they have a little, there's some in the ear, for example, and then up here epiglottis as well, but they have greater degree of flexibility. And so there's not as much, but they are found generally, so think of elastic cartilage as being that bendable part of your ear, or your epiglottis, which is going to be flexible, keeping all the food going down one pipe and the air going down the other pipe. And then finally, we have the fibrocartilages. And so these are a little bit more of kind of like the shock absorber um, types of cartilages. So you're going to find those in between the vertebral discs, for example, or in the joints, the knee joints. Here is pubic symphysis. These are going to be dealing with that wear and tear that's going to be happening between lots of the heavier or more mobile joints, and definitely those that are going to be vertically kind of pulling down because of gravity and all of that. The next thing I wanted to talk about is some of the general shapes of bones as well. Um, so we'll have the long bones, flat bones, irregular bones, and short bones. Okay, so here's how the naming goes. A long bone is longer than it is wide, right? And that is in contrast to, say, a short bone, which may have like a wider piece here than it is actually even long. So there's that. That's how to differentiate them. Humans have a lot of long bones, especially in their hands and their feet. You wouldn't think of it, but these like a lot of your phalanges, right? The phalanxes, they are technically long bones, even though they feel teeny tiny, right? It's because that wider element, right? That's mainly where we're naming them. So they have to be longer than they are wide. Okay, so flat bones are found throughout the body. A premium example of a flat bone is going to be the sternum. Irregular bones don't fit into either category, so they don't really have like a length width issue. They're not usually flat, but they might have quite a few processes, for example, or like unique characteristics in terms of the body. And so, irregular bone in this case is a vertebra. Okay, so that is just the basic introduction. So now you know a few things. You know about the general shapes of the bones, but you know what? I do kind of want to throw this one in because it is really important. So let's talk also about these right here, these little patella, right? Your kneecaps. These are a type that we call the sesamoid bones. Um, right. So sesamoid bones are bones that are not initially part of the cartilaginous skeleton. For example, patella grows within the ligaments here and kind of elongates and elongates. Like if you put a little kid, like a 2-year-old, and you sit them down on a little bench, you'll notice their knees don't do the curvature, right, that we would see in, say, an adult knee. They're going to be a little bit more of a whoop, whoop, almost, right? Like just this perfect straight down. And that's because that sesamoid bone is still developing. Some sesamoid bones also develop in like the wrists, for example. Sometimes here, there's a few known to develop in and just anywhere where you have like some of these ligaments that might be under quite a bit of tension. Right. So, all right. So those are the classes. I'm pretty happy with all of that. Okay. All right. Well, I hope that was helpful, and I'll see you again soon, I'm sure. Bye bye.